Hey, Kiran, welcome to our Tech Talk interview series today. First off, for our new listeners or people who don't know you yet, can you give us a little bit about your background and how you came to work at Novi?
Yeah, so I work on the sales team at Novi currently. I did my PhD in geology geophysics at UT here, and then worked in sort of social media, data engineering, data science, things like that before starting at Novi as a data scientist for a couple of years, and then finally switched over to more customer-facing problems. So I've been a little bit on sort of the internet side of the industry as well as the oil side of the industry, and both in technical and sales roles. So I understand the problems that we're talking about here from a very first-hand basis.
Yeah, so you've spent a lot of time actually building data sets and models for our customers, correct?
That's right.
Yeah. So what percentage of your time would you say for a machine learning model, whether that's in oil and gas or in some other industry, would you say is taken up actually putting the data set together rather than running the model and reviewing the results?
Yeah, I think if you're really starting from scratch, you could be looking at 80 to 90% of your time and building machine learning processes, just cleaning up data. And that in oil and gas will be some combination of mixing up your private data with whatever public provider you have. If you think about well header files, production, and subsurface, they're just three completely different data structures, and you're going to have to manually build a table together that represents those three crucial categories of data somehow, and that's just something you can't get around. In the internet industry, you have similar issues where you are logging maybe millions of smartphones, and you're going to have to find a way to coalesce that data together and make it something sensible before you can even start to think about training a machine learning algorithm. So it's a similar structural problem. The kind of the diversity and scale of the data is different for both industries, but either way, if you don't design a automated solution or process behind this, you could end up spending a large majority of your time just dealing with data wrangling.
Can you give us an example of some of the domain specific calculations to oil and gas that are really required to build a machine learning model?
Yeah, if you think about something simple like your production of a well versus how much proppant was used to complete it, right? So that production of a well is going to have a time series data structure, and that time series is probably going to be downloaded from a public source or even your internal database in calendar days, and then your proppant is going to be listed on some permitting form as some large number in terms of pounds. Now, you probably are going to want a lateral length normalize that. So then you have to bring in the lateral length of the well, potentially from a directional survey, and normalize both numbers by that. And then you also have to create an apples to apples comparison of all your wells. So you're going to have to convert those calendar days to flowing days. And then finally, bringing in subsurface, that is just a spatial grid across a map of the Earth. And so you're going to have to figure out a way to assign the porosity value that you have in your subsurface model to that one single well, boiling it down to one number and some intelligent way to do that. So those are three very different data structures that you're going to have to figure out some way to coalesce into one single table if you want to, either train a machine learning model or just do kind of simple descriptive statistics.
Yeah, that's a great point, Kieran. And we'll commonly come across customers who will kind of ask us whether or not they need to do the subsurface extractions to the wellbores themselves, because it can take them days of a geologist or geotech's time to do those type of extractions. That's something that happens automatically in our data engine software. So you don't have to worry at all about doing those spatial extractions of the subsurface to the horizontal wellbores. I'd like to ask you about another data type, and that is spacing. And really, spacing is something that it's obviously essential for our customers whenever they're attempting to analyze the production of these horizontal wells. Once we did a spacing comparison with an operator who was calculating their spacing by measuring everything by hand in a GIS platform. Can you talk about how our spacing calculations are done automatically in Data Engine, and how that can save a lot of time for people who are kind of doing this with the point and click method, or even something that's a little bit more advanced than that?
Right. So this kind of blends in with our theme of combining these data sources that have totally different structures. So if you think about spacing, probably where you want to start is a directional survey. That directional survey now has thousands of rows for each well as you're tracking the well through the subsurface. And that is going to be now a whole new data type. And it's a big data, category in terms of the number of rows generated. It also does not conform to the header file at all, because the header file will have 1 row per well and your survey is going to have thousands. So what we do is we first look at the surveys independently, and then we use those to figure out where the heel and the toe of the well is. And then we track these distances between neighbors. So we track both staggered neighbors, vertical neighbors, horizontal neighbors, and then crucially, our spacing is taken at snapshots in time. So if you just look at a map of all of the wells in your acreage and you start to draw lines between your sticks, you could be drawing a line between a well that was completed in 2015 and a well that was completed in 2019. When what you really want is that well that was completed in 2015, you want to know the spacing through time. So you want to know what was it like in its first month of production, its 6th month of production, first year, second year, things like that. So our spacing calculations both incorporate those directional surveys and then generate you a time series of spacing history for each well, which is really the way that we have to understand the problem.
Yeah, thank you for that. It's a big challenge. I want to talk about the data management problem, because that's something that when we go out there, we talk to operators these days, something they a lot of times will really struggle with is managing, handling, organizing, merging, and joining across, their data, subscription data. Maybe they have data across multiple assets that's held in different schemas. Can you give us an example of just how bad this data management problem can get and how that can affect your model building?
Yeah, let's say you're an operator and you have acreage positions in 2 basins, and you also you understand the value of data, so you pursue trades with other companies. So now we're already dealing with 3 different sources of sort of production data potentially that are not going to be conforming to the same structure. So that's your Midland production, your Delaware production, and then your Midland trade production that you got from another company. And that's only assuming you did one data trade with one company. And then you're probably also paying a hefty amount of money to one of the third-party data aggregation services, because you want to know the production of all the public data wells that you don't have proprietary access to. So now we're dealing with 4 different production sources, all with different structures, and you're going to have to get them in the same place. You're going to have a uniform way of understanding the flowing days for all of them. And then you're going to also have to make sure all the units are the same. And then you're going to have to make sure that everyone uses the same API number format if you ever want to join those to a header table or a survey. And then also you also need a way to extract those GeoGrid locations. So our data engine platform does all of that with simple uploads. So you would basically take all of those 4 different files, upload them in, and it would create for you that unified file, so that you would never have to go scrambling around wondering how do you find that production for that well that's operated by a different division in your company that operates that asset, or that other company gave us those data trade wells and no one really understands the format they're in, or we forgot something like that.
Yeah. So, I mean, the most egregious version that we've seen of that is operators, this has actually happened, not being able to get their own data to run through a model. And so just passing us third-party subscription data to use instead of relying on their hard-earned internal data, which that did actually happen.
Right. So you're the operator, you drill the well, you generated that data. Obviously the oil is worth something, but the data is worth something too. So that's part of what you get out when you drill a well, is you get your proprietary data around it. And it's just a huge waste to have that data and not use it, and just use the same less accurate public version for the production of that well, when you have a competitive advantage and that you have the true daily numbers for that well. And to not use it because you haven't gotten your data management order is just a huge lost opportunity.
Yeah. So can you tell me a little bit about what actually comes out of Data Engine, when the customer finishes arranging everything, building out all of their mappings and units and all the stuff required to merge and blend all that data?
Right. So what comes out of Data Engine is basically a simple table that you could load into like Microsoft Excel. And it is one line for each well. And then the columns will correspond to those major categories that I was talking about. So you'll have the processing of the directional surveys. You'll have the exact location of the heel and the lateral length processed out of the directional survey. You'll have that production time series for oil, gas, and water. And that'll be in terms of flowing days. And we'll also give you the calendar date. So you'll have, cumulative oil at 90, cumulative gas at 90, so on and so forth. And that can go on in, whatever day increments you want, out to however many days you want. And that's each production number will have its own column. You'll have the header information. So that'll be your total proppant used, total fluid used, stages, things like that. And then you'll have your subsurface information, which will be spatially extracted from the grid and then assigned a value onto each individual well. And with the headers in the production, I think one of the big advantages is that if you do have multiple sources, if you have your private data as well as the public data subscription, you'll get a unified column which represents the best you have available to you. So when it says total proppant, it'll look to your private data and then look to the public version of that, and then give you the number that you kind of gave it in order, the number that you have highest confidence in. So it's a way to kind of answer the quality quantity trade-off and get everything in one place.
Yeah, that's a really important value of Data Engine. So talking about value for customers, we see Data Engine really bringing kind of two main ways of adding value. First is huge time savings where you don't have your very highly paid engineers, techs, analysts, IT staff putting together these data sets and spending weeks assembling things. Instead, it's like something you can do in an afternoon. Could you describe? I know we recently had kind of set a new record for data sets now that we built Data Engine. Can you tell us about that one?
Yeah. So recently we had a large Permian operator come in, and it was very similar to the situation I described before, where they have their own private data in 2 basins. They have data trade data, and they have multiple public subscriptions from third-party data providers. And the first thing we had to do before we could even start talking about making a machine learning model is coalesce all that data into one table. And we basically were able to turn around for them a totally managed data file with all of the metadata tracked as well, which is available to the user in less than a day. And so now that entire company, nobody will ever have to ask the question, hey, like, how do I get the production number for this well? Or does anyone have any clue where to find the directional surveys or things like that? Everything will always be in one place for anyone in that company to see.
Yeah, that's a pretty compelling value proposition you've just laid out there. So tell me, is this Data Engine, is it something that's just for use for the Novi models, or can the users use the data for other purposes?
Well, luckily, Data Engine is one of those things that we designed for a purpose and then ended up having way more purposes. So we designed it for the purpose of you need to have your data management system in order and analytics ready data sets if you want to make a machine learning model. Now, the ancillary benefit, which is actually a huge benefit you get out of this, is once you have all of your data in one place, you can use it for descriptive statistics. You can do spatial mappings of this data. You can do all sorts of data analysis type of functions, as well as build machine learning models. So that makes the Data Engine product actually provide a utility to much more functions within a company than the machine learning side of it, which is also important. But now you can have geologists understanding the interaction between subsurface and spacing and production altogether, because they don't live in a data island anymore and the silos have been broken down, and they can look at everything and how all of these things are playing across each other. Because it's not just, if I raise my completion by this much, how much more am I going to produce? That question is hugely contextualized by what kind of rock you're in and how you space those wells. So you have to think about everything together.
Yeah, that's a great point. Really, what you're talking about is just getting the maximum value out of the data today. So no need to spend months or years, huge amounts of time arranging, joining, doing all those complex things, but do it fast and get to that maximum value for your hard-earned data today.
Yeah, I mean, I think the way that a manager in an oil company should think about this is just as waste. If you have data and you are not getting the max value out of it, it is being wasted. And that is, just as much of an economic waste as pumping proppant into a well that you didn't get any uplift from. It's money going down the drain.
Which we can also help you out with.
True.
Okay, great. Well, Kiran, thanks for your time today. Lovely Hawaiian shirt. It's I guess it's pretty much summertime here in Austin already, so time to bust out the Hawaiians.
All right. Good talking to you, Ted.
Thanks.